there's a vehicle on the pad the night of the launch. Unfortunately, you can't see the lightning and the rain. As we depart our quarters heading out to the pad, once again, it doesn't show, but it was raining cats and dogs. And I think each of us in the crew were not real confident that we were going to get off. Here's a picture in the cockpit before liftoff. That's looking over Richard's shoulder. And we got off a little bit late, but we did get to go. And the 3 main engines started just fine and were running very smoothly. When it was a little bit of vibration in the cockpit, the SRBs lit off and it became very bright, as you can see right here. It was just like day in the cockpit. And all during first stage, we didn't need lights in the cockpit. It was plenty bright. The vibration was pretty much like other crews have explained in the cockpit. During first stage, we were shaking around a little bit, but nothing you couldn't handle. And from reports that people on the ground, they got a pretty spectacular show. From inside the cockpit looking out, it looked like you kind of expect it to look like at the top of this. You were looking into a cloud with a bright light. I mean, it was just a glow all around the cockpit. And once we got up away from the ground a little bit, you couldn't see the ground anymore, and it just looked like you were in the middle of a glowing ball.
Which we were.
Which we were. You can see out the windows there. That's a sort of a representation. Here we're going through, well, you just went through the cloud deck there, which kind of reflected a little more light back in the cockpit now. This is just going through the cloud deck at about 20,000 feet. You can see the vibration isn't too bad, and we're all in there busily checking our instruments, being sure everything is running properly. The next scene you'll see from the cockpit is when the solid rocket boosters departed, and that was really a bright flash. And after that, there wasn't as much flashing or brightness in the cockpit until the external tank. There's the SEP with the SRBs. That's when those rockets push it away and it really gets bright.
Okay, once we got on orbit, the view from space was just spectacular, and this is just an indication of that just from the cockpit. One of the objectives of our mission was to deploy the INSAT satellite, and this is the cockpit arrangement associated with deploying the satellite. In this particular view, Dan is actually operating the 16mm camera, panning the cockpit. You can see Dick over there on the left. He's sort of supervising the operation. There's Dale. He's going to be handling the cameras and the switches. And I'm working from the commander's seat up front, sending out commands through keyboard and talking to the PAM and a satellite through CRT display. You can see, as I said, that was basically our arrangement. Dan sat in the pilot seat during this operation, sort of monitoring the motion of the vehicle, making sure that it was steady and that there were very few vibrations of any sort. There's a picture of the INSAT actually being deployed from the spacecraft. You can see that the deploy went very smoothly. At the moment of deploy, there was a large thump, and as I said, the spacecraft was deployed very smoothly, and there was no vibrations or no precession of the satellite as it left the payload bay. Matter of fact, Dale pointed out that about 1 minute 20 seconds after deployment, you could see some of the jets on the spacecraft actually firing as part of the nutation control associated with the spacecraft. Another aspect of our mission was checking out the TDRS network. And so the shuttle flew various different attitudes during the mission, checking out the KU band, and this is the picture of the KU band antenna that was used to check out the TDRS satellite. We found that the communications were excellent, both up and down, and that's going to be a real advantage for us on future missions.
Another task, of course, was the work with the RMS and the PFTA, the Payload Flight Test Article. In this view, I had the 16mm camera and tried to give you a look at what the RMS, the arm, looks like in its normal berth position. Here it is stowed as it is for launch and entry, and those times on orbit when it's not actually being used, it actually rolls in on those pylons, those mounts that you can see on the bottom. This is a view in the aft flight deck. I'm over at the arm station, and Richard's to the left to fly the vehicle. Here you can see the arm going in towards grapple fixture number 5. Remember, that's the one on the front of the PFTA. You can see here it looks like we're losing the view of the arm as it goes behind the DFI pallet in the front. However, from the cockpit, that was a very comfortable thing to do, and it never appeared to us that we were getting close to contact. This is lifting the PFTA out in direct mode, where I'm moving one joint at a time, again on grapple fixture 5. And here's a shot with grapple fixture 2. A lot of the tests were putting the arm and the PFTA up in various configurations and then putting pulses into the orbiter or into the arm and seeing what the relative motions were between the two. So while we were doing that, of course, we got some fantastic views of the Earth down below, and had the cameras always at the ready to get good pictures. Arm operations were extremely smooth. Richard and I had no problems operating it from the aft flight deck. You can see that we didn't bother to restrain ourselves in any way when we didn't want to, and the whole task was very easy. We did on flight day 5 something that surprised us all as far as the views go, and that is a look at the underside of the vehicle. This task has always been in our repertoire. It's been in the checklist, but we've never had to use it. Dick worked on it some in STS-2 in anticipation of being able to look at tile. Here you can see the view of the underside is extremely clear. And again, these are 16mm movies made off the TV film, so the TV is really much better than this. Here we zoom in, I think, on one of the elevons. This is the port elevon, which is down a little bit, and you can see that with the real VTR film, you're almost able to make out numbers on individual tiles. We're really surprised at the great view that we got with this technique. The arm, of course, was hidden from us. It was down around the bottom of the vehicle, so we really couldn't see it. This series, you can see some vernier jets firing in the back of the vehicle, and after the next one, watch how the vernier jet firings excite the glow around the ohms pod. You can see it there. It gets very bright for a few seconds and then slowly fades away. But even at its dimmest, you can see that you can still see the glow, and it was even more apparent to us with our eyeballs. Here we're setting up for an on-orbit ohms burn. We're getting some things ready in the mid-deck. There's the ohms engines firing out the back, and now watch what happens in the mid-deck. That's 1/16 of a G. Each of the ohms engines is 1 foot per second squared for a total of 2 feet per second squared, and that 1/16 of a G felt like a lot to us after being up there for 3 or 4 days. And you can see the acceleration on the tape. It keeps wanting to go back towards the aft bulkhead because we're accelerating forward towards the left of the screen. This is the final work on one of the Cephus samples. The sample has already been separated. The cells are in individual partitions in that tray. You saw me there shaking the tray to make sure the cells mixed with the nutrient materials that had been previously placed in those cells. I'm now putting the whole collector tray back into a cooler where it remained for the rest of the flight. Bill?
Yes, this is an old man in space taking a walk on his walker. And here we have some of the long-suffering crewmen being subjected to a variety of studies looking at various aspects of the vestibular control system. The electronics there work very well in that mode. It's rather simple, but I would compare the quality of the records and such that we obtain to those of labs on Earth. This is another aspect looking at how well one can coordinate eye and hands in a complex tracking task. And then finally, I guess most of you have seen these, in which you turn your head while you track both the head and eye motion, which again allows one to see how well the eyes are capable of tracking and how they're affected.
These next few scenes just show some other activity. You'll notice how clean the middeck is. We kept it this way the entire flight. Now, actually, I'm going down there to change the cabin temp controller, which is underneath the middeck floor. And you can see just by floating and an occasional toe leaning up on something that you can do your work. And it's one of the reasons in zero gravity and on orbit that people can work such long hours and not get tired. It's just a delight to work in that environment. This is a little scene on preparing a meal. Each of these each is an individual food tray, and we've had. You'll see here in a moment. We've had several calls for guys for Major League Scouts, looking for infielders. But generally, after a couple of days on orbit, we found that one or two of the guys could set up a meal for all of the crew in just 8 or 10 minutes, and it was quite convenient and provided a really nice way to stop work for a little while and have a hot meal. It was a lot of fun. This is, as a task, about twice a day we had to change the lithium hydroxide canisters also underneath the middeck floor. We had a shopping list of just engineering duties that we had to perform that we've on each of the flights we're trying to record just so that training for future crews can go well, and this is an example of one of them. These canisters are used to scrub the air so that it'll be clean and easy to use. You notice this is that the seats, except for the commander's and the pilot's seat up on the flight deck, the mission specialist seats for ascent and entry are dismantled after you get on orbit, and they're very difficult in 1G and very heavy to manhandle to install. So this is real time. We set up a camera, or at least Dale and Bill and Guy did, and in about 2 minutes from the time they untaped the chair until Dale had strapped into it and was sitting there was just a couple of minutes, and it's just a good example of how easy it is to work in zero gravity. That kind of ends up our own orbit part of the film. Now we're going to talk briefly about the entry and landing. This is 16 millimeter photography taken by Dale of the front windows. Again, you can see the glow, which now is orange in color. And as we described before, these are the pulses taken by Dale by holding a camera and looking aft and above his head, above the tail. We have, and this is real time, incidentally. This pulsing is happening at the frequency that you're seeing it. It is not understood at the moment. We've shown it to the thermal folks, and it's going to take a little thinking to describe what it is that we're seeing. This is probably a little long for the press conference. We left this entire sequence in so that our engineering friends could take a look at it. One last shot panning of the cockpit with the glow. As it started out changing colors, up high it was sort of a salmon color and finally got white hot. This is the landing as seen through an infrared camera that was out at Edwards, transported down there from the Navy Weapons Center at China Lake. You'll notice it's infrared, so actually the vehicle was not visible to anybody that was there at this point. The brighter areas are the hottest, and so you can see the red hot or white hot nose cone there. And if you look carefully, you can see that the window areas are also hotter. It's so good that you see the gear deployment, and you can see that black area are actually the cold rubber main tires. And we defy Hollywood to match this sequence. This is the Challenger coming in for landing on runway 22 at Edwards. You'll see us kicking up a little bit of dust off the runway surface. There's a touchdown, which was fairly smooth, and all I can say for the landing is my hat is off to the people that helped us develop the heads-up display and the night lighting system, and to the great work that was in support for the last year, generally in the middle of the night, to the folks out in our shuttle training aircraft that provided Dan and me with the training that it took to accomplish this first night landing. Finally, at the end, here's the crew holding on for dear life to the rails to make sure they don't embarrass themselves walking down these steps, but actually by now, everybody was readapting quickly to 1G. And I hope this movie portrays to you the fact that we had a lot of fun on the flight, because if it does, it was certainly accurate.